Welcome to video N4. We're going to solve a linear Diophantine equation with the right-hand side not equal to 1. So there will be one tiny additional step in this problem. All right, here's the problem. Find all integer solutions to 5x plus 22y equals 18. All right, just to speed things up, step 1, let's see if there are solutions. The GCD of 5 and 22 is 1. 1 does divide 18. 18 divided by 1 is 18. So there is indeed a solution, which means infinitely many. Step 2. Use the Euclidean algorithm to find the GCD of 5 and 22. All right, so I'm going to write the larger number first. 22 is what? 4 times 5 plus 2. Bring these over. 5 equals 2 times 2 plus 1. Bring these over. 2 equals 2 times 1 plus 0. Stop. And then the GCD, once again, is 1. Okay, the next step is to use the Euclidean algorithm in reverse. So I'll do that right here. Again, I'm solving for the right-hand side. So I'm going to get 1 equals 5 minus 2 times 2. Use the step above. 2 equals 22 minus 4 times 5. Okay, so just substitute this into there. So I'll go blue now. And I'll obtain, in this equation up here, 1 equals 5 minus 2 parentheses 22 minus 4 times 5. Okay, so one thing to keep in mind, I didn't really emphasize it before, our original coefficients are 5 and 22, so we really want to be getting 5 and 22s here. So I'm not going to multiply 2 times 22 to get 44, I'm going to keep it in 2 times 22 form. Okay, so just one thing I should have emphasized earlier. All right, so now let's distribute. 1 equals, and I can go 1 times 5. Again, I want to keep those coefficient numbers. Minus 2 times 22 plus, I'll make this be 8 times 5. Again, just so you know, we're keeping 8s and 5s. And then I've got a 1 times 5 and the 8 times 5. That's going to be a 9 times 5. Okay, so there's my 5, there's my 22. I've got one small problem. If I rewrite the original problem is 18 equals 5x plus 22y. I've got my 5s, I've got my 22s. I have a slight problem here. I don't have an 18. So what I'm going to do is simply multiply the left side by 18 and the right side by 18. And then I'm essentially done. So I'll do that. So I'm going to multiply the whole left side by 18 and the whole right side by 18, remembering to distribute. So I'll show that step over here. So I'm going to get 18 equals 18 times 9, I'm much better with 18 times 10, that's 180. Take away an 18, that's 162. Minus 18 times 2, that's 36. And now I've got the 18s, I've got the 5s, I've got the 22s. I'm good to go. So this is my x naught. This is my y naught. And my general solution would be x equals 162 plus the other coefficient, 22n. Y equals negative 36 minus the other coefficient, 5n, where n is any integer. All right, so this is going to be the last video on Diophantine equations. If interested, you might want some more practice. So what I suggest you do, if you want more practice, is simply Google the following. Linear Diophantine equation solver. You could make up your own equation, solve it, put in the A, B, and C, and have the internet site give you a solution and check to see if you're correct or not. And in general, you can do that with any of these topics. There's usually online solvers for many of these. Or you can even just Google the topic. Okay, so there you have it. How to solve a linear Diophantine equation where the right-hand side is not equal to 1.